let me enable the compilation for the WebAssembly platform. So, and see how it is going to fail. Okay, so I wanted to recompile actually this entire stuff. Is it going to fail? It didn't really fail that much, which is nice. So let's actually go to here and let me take a look at the console. Okay, it is trying to call to memset. So this is what's interesting about WebAssembly, right? So the program is trying to call to a libc function that is not implemented. So we have to start implementing libc in JavaScript. Yes, that's what we're doing on this channel. We're implementing libc in JavaScript in browser. So let's go. Okay, so let me see. We need to implement memset scnn, right? So let's go ahead and implement that. So what we need to do, we need to take the chunk of memory, right, of the size n that starts at s. Right, so to do that, we need to get that memory. So here's the WASM module, but we don't really have a global access to the WASM module, unfortunately. So and this is something that we'll have to fix, right? So let's actually make a global variable that refers to the WASM module, right? And here, as we get the WASM module, we're gonna actually assign that WASM module to W, right? I actually want to rename that. I'm going to replace WASM module with W0 to indicate that it's a thing that we initialize this stuff with. But for this one, I'm going to query replace with W. There we go. So this is like a purely preferential naming. Nothing particularly special, purely preferential. And another thing we can do in here, we can do something cool. We can align by regular expression. Boom, look how nice it looks like. Can your Vim do that? Tell me, can your Vim do that? It cannot do shit, bro. I'm joking. Though, to be fair, like, I couldn't find the analog of align by regular expression in Vim out of the box. I know that you can write an extension and stuff like that, but out of the box, like, I couldn't find anything like that. But in Emacs, it actually comes without out of the box. So, and of course, like, I mean, the text editor is equivalent. If there's something lacking in one editor, you can always just implement it, right? They all have like a Turing complete language in them. So, all right. So null. I probably want to do query replace null and say null 64. Right. Okay. So in memset, we need to take the buffer, right? So this is going to be instance, exports, memory, buffer. So here's an interesting thing, right? So when you work with WebAssembly, but in JavaScript, you have a memory literally as an array, right? You have a buffer, and if you modify that buffer, you literally modify an internal memory of WebAssembly. Right, so if you've got a pointer, it's gonna be an index of the byte within that buffer. Right, so essentially to dereference that index, you do something like this. Right, I dereference that index and I got the byte out of it. Right, so this is how you program like a low-level JavaScript, if that makes any sense. Does he compile JI to WebAssembly and then run it using JavaScript? That's precisely what I do. That's precisely what I do. If you're interested how exactly I do that, I actually created like a proof of concept that demonstrates how you can do that as well. Right, if you have a JI compiler, of course, right? So this is like a complete example that demonstrates how you can do that, right? And this is how it looks like, right? So this animation is being generated pixel by pixel in real time by WebAssembly module generated from a JI program, right? So this animation is being drawn by JI. Pixel by pixel, by the way. It's pixel by pixel animation, right? So, and everything is documented in this repo, Right, so if you have a Java compiler, if you're one of the beta tester, you can try to replicate this thing on your machine as well. But it only works for Linux now, right? Because like I have a Linux environment and Microsoft does not provide Windows in my country anymore. I mean, I can always pirate, but I mean, that's besides the point. So yeah, anyway. Oops. Yep. Anyway, so let's continue. All right. So the cool thing is that we can actually take a slice out of the buffer, right? So I can do uint8 array, and I'm gonna say that okay, use buffer and start from s and take the size n, right? And here we can have something like how can I say that? Like a chunk. Let's call it chunk. And I'm gonna do console log chunk. And let's see how it's gonna react specifically to that. Cannot convert big int. Oh, okay. So s is actually big int because it's a 64-bit integer. 64-bit integers. So it's a number. So this is what I'll have to do. And I wonder if I have to do that for both of them. I think it's for both of them. Yeah, there we go. So this is the chunk of memory we got. So that means game was trying to set 4 kilobytes of memory. Right, and as far as I know, you can do uint8 array fill, right? You can literally fill it. Okay, so we have an analog of memset in JavaScript, which is nice. Right. So, and you can actually set the value. So I can do the following thing. I can do fill with C. And if I remember correctly, memset returns the pointer back, right? So it takes the pointer and also returns it back, right? I don't really know why, but it does that, right? Okay, so let's actually try to see if it works now. And looks like it worked. It just like memset memory, and it didn't try to do anything else.